So in this video, I'm going to go through what we went through in class, just in case you missed something or you were absent. So we're looking at areas of triangles, trapezoids, and kites. And so area of a triangle here, and this goes for any triangle, right triangles, non-right triangles. The technique to get the formula is first we're going to call that the height, and then we've got the base, and the next thing we're going to do is create a copy of itself and turn it into a parallelogram. And then we know that the area of the parallelogram is just base times height. So we're using this base and this height to find the area of this entire parallelogram, but then the parallelogram is too much. So we essentially just want to get rid of that copy by dividing by 2. And so that's how we come up with this area of a triangle, area of any triangle, base times height divided by 2. So even if you've got a right triangle, you can call this the base and this the height, or you can flip it around. Oops, that's not flipped around. Neither is that. You could flip it like this, and you can call this the base and this the height. It doesn't matter which one's which for a right triangle, or even if your triangle looks like this. Just don't use these slants as the height. Those are not the height. In this case, the height would be from here straight down at a 90-degree angle. Another name for that is altitude. So the next slide, we go through an example. So we've got, just find the area of this triangle, and a lot of times you're going to be given some irrelevant information, like the 6 here is the height of the slant, and so we don't want that. We just want the 5 is actually the height of that triangle, and 8 is the base. So we just do 8 times 5 divided by 2, and that takes care of it. So I'll have the equation pop up here, right there. So you could also think of the formula as 1/2 times base times height, which is the same thing as dividing by 2. Okay, and so next example, we'll go through how to find the area of a trapezoid. And so first thing we do is label, that's the height. And we've got 2 bases, because we could look at this in 2 ways. So we'll call that B1 and that B2. And then we're going to do the same thing we did with the triangle. We're going to create a copy of itself, an exact copy. But now the bases have flipped. So B1 is now up there and B2 is down on the bottom. And so then we know the area of a parallelogram is just base times height. So, but the base of this trapezoid is this whole thing. Think of that as the base. And so that's actually B1 plus B2. That's the base. And then times the height, just h. But then we have to divide the whole thing by 2 because we've got 2 trapezoids again. So we've got twice as much as we need. So that is the area of a trapezoid. Okay, B1 plus B2 times h over 2. You could also move this h into the front. It doesn't really matter where it is because it's just going to get multiplied. So now we'll look at an example. Okay, so I'll leave my formula up there and just erase this line here. So find the area. Again, try to sort out the irrelevant information. That's going to be this slant. We don't want that information. So we just do B1 plus B2. You can go ahead and do that first because it's in parentheses. Then times the height and divide by 2, and now you have some choices. You could multiply 20 times 6 first. Sometimes that's a harder number to do in your head. Then divide by 2. Or you could go back and divide one of these. Just usually I pick the highest number and cut it in half once. But don't cut them both in half because that's technically not right. You can only cancel one of them. So then we get 10 times 6, which is also 60. Okay, on to the kite. So the area of a kite, I've got it broken into 4 triangles because that's what a lot of people like to think of a kite as. 4 right triangles, and then you find all the area of all the triangles and you add them up. But that's a lot of work, especially when maybe you're missing some information. So really the best way is to split out these parts and make a rectangle. Okay, so notice how the blue and the red, just change them around and we get a perfect rectangle at right angles. And now we want to label everything. So we're going to call that diagonal 1. So the D1 stands for diagonal 1. That's always going to be the one that cuts through the vertex angles. Okay, but then diagonal 2 is the one that cuts through the non-vertex angles. It's the one that gets bisected. So in other words, remember for a kite, this side is equal to this side. And so you'll notice that this base of the rectangle is only half. It's only one of these. So that's why we've got this 0.5 D2. So if we want to find the area of this rectangle now, we just do base times height. So 0.5 D2 times D1, but there's really just, a better way to write this. We can just rewrite D1 times D2 and divide by 2. That's probably the best way to deal with this if you're actually calculating. Okay, so I hope you can see, and it does matter which one's diagonal 1 and which one's diagonal 2. Diagonal 1 is always the one that cuts through the vertex angles and it bisects the vertex angles. And then diagonal 2 cuts through the non-vertex angles, but it does not bisect them. However, it is bisected by diagonal 1. So diagonal 1 cuts diagonal 2 in half. Okay, so let's look at an example. Okay, here we go. Find the area, and I'll show you kind of a couple different ways of thinking of this. So again, some people like to try to find the area of all the right triangles, but that's not really possible all the time. It is on this one because we're given this is 9 and this is 12, so you could do 9 times 12 divided by 2 and get this triangle, and then another one, and then do all 4, but I think that's just too much work. Really, the easiest possible way to think about this is just take the diagonal 1, which is 9 plus 16, okay, and then diagonal 2 is always going to be cut in half perfectly, where these two are the same. So instead of dividing by 2, we can just use one of these in our calculation, and we've already cut everything into 2. So this answer is just going to be 25 times 12, okay, which is going to be 300. Now, if you really, if you don't see that and you just want to follow the formula, that's also fine. Just identify diagonal 1 is 25, and diagonal 2 is actually this whole entire length, so it's 24. And then we take this whole thing, divide by 2. So that's what I did here. 25 times 24 is 600. So if you got a calculator, you could do it that way, and then just divide by 2. Okay. So, yeah, and I showed the shortcut right there. So that is it for this intro to triangles, trapezoids, and kites.